In the profundities of the room, the James Webb Space Telescope has seen something absolutely stunning: grand lights incredibly suggestive of Earth's clamoring metropolitan locales, communicating from Proxima Centauri b, an exoplanet 7 trillion miles away. Are you organized to stand up to what lies past the stars? Might we at some point try to stop and examine what may be possible in tracking down a headway not our own? What advantaged pieces of information could they, whenever held, offer, and what does this mean for humankind's future? As the world wrestles with the ramifications of this upsetting find, the James Webb Telescope's most recent observations propose something a long way past what we may expect. Might these lights at some point be conscious signs from a high-level progression on Proxima Centauri b? Each glint and fast development over this huge distance invites speculation that we may be near the edge of the most astounding divulgence in mankind's set of experiences: contact with a different universe. This piece of space, once remembered to be serene and ruined, now murmurs with the possible presence of life. With every piece of information we gather, we inch nearer to potentially rewriting history. As the telescope explored the limitlessness of space, it found something charming on Proxima Centauri b. The far-off exoplanet emitted lights that seemed to resemble those from metropolitan organizations on Earth, suggesting the possible presence of an unfamiliar human civilization. This thought has ignited huge energy and interest among researchers. It could very well be the discovery they've been sitting tight for, featuring the presence of intelligent life forms that could be coordinating their networks in ways we've never imagined. David Kipping, a cosmologist at Columbia University, described the planet where these lights were seen as particularly complex. This complexity arises because, unlike most rocky planets that absorb sunlight and emit infrared energy, this exoplanet acts remarkably due to its unique relationship with its star, Proxima Centauri. However, this isn't the only dazzling aspect of the discovery. The James Webb Space Telescope's findings highlight how powerful this device truly is. The telescope's capacity to detect infrared light was crucial in observing these remarkable lights, showing us how much more there is to gain. The signals from Proxima Centauri b are vital for understanding what its atmosphere may resemble. Researchers need to continue using this telescope to explore the planet's climate and determine whether it could actually support life. The James Webb Telescope excels at detecting infrared light, which allows it to observe Proxima Centauri b's nighttime activities. Many space telescopes struggle to detect faint lights in the vast, indistinct expanse of space, but the James Webb Telescope can capture even the smallest flickers. This makes it ideal for checking if the supposed city lights on Proxima b's dark side are actually artificial. The telescope can identify artificial lights in space if they emit within a specific narrow frequency range, much stronger than normal starlight. Proxima Centauri b has a close relationship with its star. The side facing the star collects energy from the intense daylight, while its shadowed side reflects some light. As Proxima Centauri b orbits its star, it experiences a constant cycle, like Earth with hot days and cooler nights. The planet shows large temperature contrasts, largely due to its position. For instance, if Proxima Centauri b didn't have an atmosphere, the temperature contrast between day and night would be extreme, with the daytime side becoming unbearably hot while the night side would freeze. These sharp temperature contrasts interest astronomers because they can provide insights into Proxima Centauri b's atmosphere. Thanks to its powerful infrared imaging abilities, the James Webb Space Telescope can measure the planet's energy output, giving crucial information about its atmosphere. Anyway, the most interesting aspect is that the telescope's orbit around Earth aligns with Proxima Centauri b's orbit, allowing it to observe the planet's normal cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step is to investigate its composition to see if it could support life. Signs like oxygen, water vapor, and methane could indicate that the planet has conditions suitable for life. Observing these elements on Proxima Centauri b would support the possibility that the planet could potentially support life, leading to detailed analyses and assessments of the light passing through its atmosphere. Here's the trick. The James Webb Space Telescope can also look at several of the closest planets that may be habitable. For a broader perspective on additional planets, researchers are eagerly awaiting the Extremely Large Telescope, ELT, which will begin operations in 2028. The ELT is expected to provide a clearer picture of what distant planets' atmospheres may be like and whether they are likely to support life. Researchers are anticipating the new insights that the ELT and other future telescopes will bring. In the meantime, the James Webb Space Telescope remains a crucial tool for studying planets outside our solar system. Despite its limitations, it continues to provide significant data that could revolutionize our understanding of the universe, now and in the future. As we move into the next era, we will further decipher these exciting discoveries, inching closer to potentially enormous revelations. Looking forward, new space telescopes will aim to block out the bright light from stars, making it easier to see the planets that orbit them. This is similar to covering your eyes with your hand to see better in bright light. By reducing the glare from stars, these advanced telescopes will be able to capture the faint glow from distant planets more effectively. This clearer view will help researchers in studying the atmospheres of these planets and determining whether they could support life. However, this is no simple task. Researchers must carefully distinguish gases produced by living organisms from those resulting from natural processes, such as volcanic emissions. They need to fully understand these distant planets so they can accurately identify signs of activity beneath the surface and avoid being misled by natural phenomena. The James Webb Space Telescope opens up new, exciting opportunities for future discoveries. As we continue to explore space, we draw nearer to understanding more about the vast universe and our place within it. As long as humanity has existed, we've wondered whether we are alone in the universe. This question still drives many researchers today. Currently, the James Webb Space Telescope is exploring distant planets and moons, looking for signs that life could exist beyond Earth. The likelihood that life could exist elsewhere in the universe is gaining momentum, and this growing belief excites many about the possibility of finding extraterrestrial life. In 1984, two American cosmologists, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI. They formed a non-profit organization to listen for radio transmissions from space, hoping to detect signals from intelligent beings. They used radio waves because these transmissions can travel vast distances without losing strength. The Allen Telescope Array in California, which includes 42 radio telescopes, is at the heart of their work. Despite SETI having listened for over 30 years, they have not yet found any conclusive signs of extraterrestrial life. Still, Jill Tarter remains hopeful. With today's advanced technology, she believes a significant discovery may be just around the corner. She envisions a global effort to determine if we are alone in the universe. Recently, excitement grew when NASA announced that the James Webb Space Telescope might have spotted something resembling artificial light from a city on a nearby planet. The James Webb Space Telescope, situated 1 million miles from Earth, is a vital part of space exploration. It sends back detailed data about the oldest parts of the universe and is specifically designed to capture details we've never seen before. This helps us better understand how galaxies, stars, and planets form. Space experts are using the Webb's advanced instruments, like its precise camera and specialized filters, to focus on the light from stars and planets. By focusing on specific types of light, the telescope helps researchers determine the physical and chemical makeup of distant worlds. However, this isn't the most amazing part. The James Webb Space Telescope goes beyond just observing. It actively studies the atmospheres of different planets, searching for even the smallest signs of activity beneath the surface. With its unmatched ability to explore the universe, the James Webb Space Telescope is guiding us into a new era of discovery. Experts have recently made significant revelations about the universe, finding much more matter in massive galaxies than they ever expected. These discoveries are prompting researchers to reconsider their theories about how the universe began and evolved. Each new discovery from the James Webb Space Telescope brings us closer to understanding the farthest reaches of space and what life could exist beyond our planet. With the help of the James Webb Space Telescope, researchers are delving deeper into space than ever before, gathering data on distant worlds that could one day help answer crucial questions about these exoplanets. Just a few decades ago, our understanding of planets outside our solar system was minimal. Since then, space experts have identified more than 4,000 exoplanets orbiting other stars. This illustrates the strength of curiosity and advancement. NASA believes these discoveries are just the beginning, suggesting that there could be trillions more exoplanets waiting to be discovered. As scientists continue their space investigations, they are eager to find where extraterrestrial life might exist. At times, they come across signs that suggest they are on the right track. For example, the Galileo spacecraft made an accidental discovery near Jupiter, hinting at possible vegetation. This was a crucial moment, marking the first discovery of what is known as a biosignature, specifically the vegetation red edge. This technique identifies life by analyzing how light reflects off it. Now, the James Webb Space Telescope is set to go further in the search for extraterrestrial life, focusing on planets that orbit within their star's habitable zones. If signs of activity beneath the surface are confirmed, they could reshape our understanding of the universe and our place within it. The search for life beyond Earth has reached extraordinary levels of complexity with the arrival of advanced space telescopes and observational techniques. As cosmologists continue to push the limits of what's possible, they are not only studying the physical properties of distant exoplanets, but also delving into their potential to support life. The technological advancements made in recent decades are crucial to this mission. One remarkable development is the progress in spectroscopy, a technique that analyzes the light emitted or absorbed by objects in space. By studying the spectrum of light from distant exoplanets, researchers can determine the chemical makeup of their atmospheres. This method has already provided critical insights into the atmospheric conditions of several exoplanets, revealing the presence of gases like hydrogen, helium, and carbon dioxide. These discoveries help assess whether an exoplanet may have conditions suitable for life. Another fascinating frontier is the study of exoplanetary atmospheric conditions. Understanding these patterns can offer clues about the climates of distant worlds and their potential habitability. For example, detecting seasonal variations in atmospheric conditions could suggest the presence of liquid water, a key ingredient for life as we know it. Researchers are also examining the potential for extreme weather phenomena, like violent storms or temperature changes, which could affect an exoplanet's habitability. The search for biosignatures, or signs of activity beneath the surface, is an area of great focus. Beyond the traditional search for oxygen and methane, scientists are investigating other potential biosignatures, like complex organic molecules and unusual atmospheric anomalies. With its advanced spectroscopic abilities, the James Webb Space Telescope is well suited for this task, offering the potential to detect subtle yet important signs of something happening beneath the surface. In addition to direct observation, theoretical models play a crucial role in guiding the search for extraterrestrial life. These models help researchers predict what kinds of signals or conditions might be present on exoplanets based on known principles of physics and chemistry. They also assist in planning experiments and missions to test these predictions. Models of exoplanet climates can simulate the potential effects of different gases and environmental conditions, guiding future observational efforts. Furthermore, the integration of artificial intelligence, AI, into space exploration is revolutionizing data analysis. AI algorithms are increasingly being used to sift through the vast amounts of data collected by space telescopes and other instruments. These algorithms can identify patterns and anomalies that may be missed by human observers, offering new insights into the nature of distant worlds. International collaboration is also playing a vital role in advancing space exploration. Researchers and scientists from around the world are working together to share data, resources, and expertise. This collaborative approach enhances our understanding of exoplanets and speeds up the pace of discovery. Looking ahead, the continued development of space technology and scientific techniques promises to bring us closer to answering one of humankind's most important questions. Are we alone in the universe? The ongoing efforts and advancements in this field highlight the remarkable progress we are making in our mission to explore the universe and understand our place within it.